All right, so now we need to talk about the osmolarity of the extracellular fluid. It's the extracellular fluid that we can monitor, that we can look at, that we can, take. All right, so that's how we assess how the body is through the uh, extracellular fluid. So, osmolarity. So, osmolarity is, we talked about this before, but it's the concentration of a solution expressed in milliosmoles per liter. Milliosmoles per liter. So we're talking about the concentration of the extracellular fluid. We know that both fluids, intracellular and extracellular, are full of solutes: sodium, potassium, chlorine, hydrogens, bicarbonate, all kinds of stuff is in there. So the osmolarity of the extracellular fluid is important because that will affect how water moves, because water moves through osmosis and it's going to follow the solutes. Okay, so how does the body monitor this? Okay, and basically the body monitors this through the hypothalamus. Okay, so hypothalamus, that is an H, hypothalamus. So I'm going to show you a blood vessel. And I'm going to show it to you in two ways. So I'm going to show you a blood vessel here and a blood vessel here, but it's the same vessel. I'm just showing it to you in two conditions. Okay, so in the first blood vessel up here, I'm going to say that the osmolarity is 270 milliosmoles per liter. Okay, and in this other one, in this other situation, the same blood vessel, we're going to put it at 310 milliosmoles. So milliosmoles per liter. Okay. So the ideal osmolarity number is at about 280 milliosmoles. And I know when we talked about the nephron and we were talking about the medullary gradient and all of that, we use 300 as what is isoosmotic and all of that and what the normal osmolarity is. We just use 300 because it's easy, all right? But actually it's about 280. So what happens? So we've got these two vessels, and this one up here is at 270. This one down here is at 310. Well, how do we change that osmolarity? So osmolarity changes when there is decreased particles, and that increases volume. So if you have decreased particles, so a low osmolarity, that means you have more fluid, so you have an increased volume. If you have a higher osmolarity, you have increased particles and therefore a decreased volume, so less fluid. So on each of these vessels, because here's the thing, the hypothalamus doesn't have some kind of stick that it dips into the blood and it's like, oh, I sense that, I can see that the osmolarity is this number. No, it can't do that. So it has to have another way of figuring this stuff out. So your vessels have little receptors on them. and these are called osmoreceptors. And osmoreceptors, these osmoreceptors here respond to stretch. So they will detect an increase or a decrease in volume. Okay, so if the osmolarity is low, so it's 270 milliosmoles, we have these receptors and they are connected to some kind of nerve that goes back to the hypothalamus. Okay. Now down here, this is the same vessel, so of course we're going to put these little osmoreceptors on them, and they too will have a nerve, a sensory nerve that comes back here. And this nerve will alert the hypothalamus to the condition of the blood, the osmolarity, based on that stretch. So if the osmolarity is low, that means volume is high. Are we going to feel stretch or not feel stretch here? Well, here, you're going to feel stretch. So stretch is going to happen. So what is this nerve going to go back and tell the hypothalamus? Well, it's going to tell it nothing. It is not going to send an action potential because it is feeling stretch. So it's feeling pressure. Okay, so no action potential will occur here. All right. But down here, we have increased particles, so we have a lower volume. So down here, there's going to be little or no stretch occurring here. So this nerve is going to send an action potential to the hypothalamus. And an action potential to the hypothalamus is going to mean that osmolarity is higher. There's no stretch there, so that means blood pressure is low. Okay. So we're low volume, low pressure here. Okay, so the hypothalamus says, you know what? No problem. Got the answer for you. And what it does, is it sends out a hormone called ADH. Another name for ADH is vasopressin. So this is a hormone that we saw and sort of talked about within the endocrine system. So now we're going to talk about exactly how that works.